In this session, I would like to talk about firepower threat defense policies. This is going to be a general discussion on those. Now, we will not go into any of the details of each of the policies because we will have separate sessions for most of the policies that you can enable on FTD. The goal of using policies is to enforce control on the traffic that is flowing through the FTD. That's the purpose of those different features. And there are a lot of them because each of the policies is supposed to affect the communication in a different way. So we can say that each policy kind of like offers a unique type of functionality. Like for instance, I have one policy that is used to enable authentication and to enforce authentication. I have another policy that I use to decrypt encrypted web communication. I have one more for intrusion detection, prevention, and I have something else to control traffic based on layer 3-4 conditions and also some other information. Okay, but now even that those policies are different and serve different purposes, they share some common characteristics. In most cases, the policy is going to be built of rules, and those rules will be processed in a top-down fashion, exactly like with an access list. For example, if I have 3 different roles, I'm going to start the evaluation with the first role. If I have a match, I'm going to leave the policy, so I will not process the remaining roles. If I don't have a match, I'm going to compare my traffic to the second role. If I don't have a match, I'm going to use rule number 3. In this case, it's the last role. I can have a match. If I have a match, all is good. I'll take an action associated with the role. Or if I don't have a match here, in most cases, there is also going to be a so-called default action, which is what is going to act as a catch-all for all packets that didn't match any of the specific roles. Now, the reason that I put a star over here is that there is going to be one exception to this rule of using that first match algorithm, which is going to be a rule that is built as to monitor the traffic, which is just logging the communication so we know that we have a match in the policy. Now, in this case, we will still process the remaining rules, but only if the role type is set to monitor. Of course, we will talk about those different options we can use in the policies, and this is just a general discussion now. Okay, so each role is gonna consist of several different elements. First and foremost, it is going to be the conditions. We want to specify what communication we want to affect. In most cases, we will be able to use multiple conditions of different types. Like, for example, in the access control policy, I can build my roles based on layer 3, layer 4 information. I can add some application level details. I can use URLs, maybe zones, and so on. And those conditions can be combined. You can specify multiple conditions, like to use the OR mathematical Boolean logic. You can combine conditions using the AND logic. We can do all this stuff in case of most of the policies. Of course, as I said, the main purpose of a policy of using it is going to be to do something with the traffic that matches the rule. This is going to be our action. And in many cases, we will be explicitly configuring those actions in the rule. Like, I can tell my access control policy that if I have a match, I want to block the traffic, or maybe I want to pass communication to the other engines for additional inspection. But there is also a concept of the implicit action. Some policies, they will just allow you to build some conditions, but there's going to be no action available for selection because the policy is meant to do just one thing. So it will implicitly do something with the traffic that matches the rule. Position of the role is also important based on that role matching logic. So we will be able to drag the roles, change their sequence number. There is also going to be that logging and comment options. So we want to leave a comment so we know what the role is for. You may want to enable logging in the role. This is pretty important because in most cases, logging in a role is going to be by default disabled. And last but not the least, policy specific attributes. This step is going to depend on the actual policy type that we configure. So SSL policy is going to have different options than, let's say, identity policy. Okay, one of the most important things to understand when it comes to working with firepower threat defense is going to be the policy processing order. Because as I said, there are a lot of different policies that you can enable, and if you don't really know how the device processes those policies, in what order, you may get into really hard troubleshooting. So the actual policy processing starts with what is known as pre-filter policy, or just pre-filter rules, because the pre-filter policy defines pre-filter rules which are enforced through a layer 3-4 access list. And those rules are pushed down to the Lina process, to the ASA. They will be always checked first for the traffic as it enters the ASA. Next is going to be the access control policy, which is more of like a master configuration, master engine that is used to control other engines or just invoke other policies. And one of the options here is going to be to control communication based on layer 3-4 source destination port number conditions, like with a regular access list. But notice that this access list comes after the pre-filtering policy, because the pre-filtering policy, as we will see in a different session, is used to make exceptions. This is like when you want to bypass the processing for the packet. Maybe this is an elephant flow, like backup communication that you don't really want to inspect but snort. Maybe this is video communication or low latency stock exchange traffic. That would be an example of where you would want to use the pre-filter policy. What is going to happen next? It is going to be security intelligence based on IP addresses. It's a method of quickly dropping packets based on their reputation. And in this case, we are talking about the reputation of individual IP addresses. Like when the packet is coming from an IP address that is known to be bad, and you will know what's bad and what isn't from the Cisco's collective security intelligence cloud, you will drop the packet. Next is the SSL policy. This one we are going to use to do the decryption of encrypted web communication. We know that encrypted communication in general is not something our engines can look at. They are not able to see what's inside of the encrypted payload. So we might want to use this policy to do the decryption first, and this way allow other engines to see what's inside. Then we will be performing network analysis for IPS, intrusion prevention, and also network discovery purposes. And network analysis is actually going to be performed at a few different places, as we will see in just a moment. Next comes security intelligence, but this time based on domain names or individual URLs. We have the identity policy for authentication. We have layer 7 application inspection, like for example URL filtering or just controlling the communication based on the detected application. Next is file policies, file control, and advanced malware protection for dealing with individual types of files and malware. And finally, we have intrusion detection, the snort engine. So to visualize this, remember that the FTD consists of two main engines. We've got the firewall engine and we've got the firepower engine. The firewall engine, this is the ASA, this is Lina, and this is what sits in the data plane. So as the packet enters the device, we will, like on the normal ASA, try to match it to an existing session. If we have a match, we will skip all further Lina level processing and we will send the packet over here to the firepower engine. Data acquisition, this is just an interface between the two individual engines. Now, if the packet was not part of an existing session, we will try to do the decryption for VPNs, like if this is part of our security policy database, the packet matches the SPD, we will potentially do the detranslation. And next is that FTD specific component, which is the pre-filter policy. So as I said, this is how you can potentially make exceptions to the further inspection with Firepower engine. Because if the packet matches your policy rule, pre-filter policy rule, and the rule was configured with a special action, making it a FastPath rule, you will bypass all other checks like access list, control, the entire Firepower engine, and you will just send the packet down here. It is still going to be processed by some other features like network address translation, QoS, VPN, but this is part of the data plane processing. Normal data plane processing, it's not part of that additional inspections performed by the Firepower engine. Okay, if we didn't have a match in the pre-filter policy, we will start evaluating our regular layer 3/4 access list. At this point, we will be looking at the roles built based on IP addresses and port numbers. So no application information at this point. Okay, next we will move up to the Firepower engine. So we handle the packet to those specific engines, and we're going to start with pre-processing, which is a method of normalizing the packets. And this is going to happen in a few different places here. So the packet is going to be normalized at different levels, like at OSI layer 3, 4, and also application layers. Okay, next is security intelligence based on IP addresses. So this is reputation-based blocking of traffic coming from known bad sources. We also have application discovery. We want to detect the application a packet kind of like belongs to. So is this a telnet packet, or maybe a web packet, or maybe something more accurate, like is this a Facebook upload, or let's say Facebook game. Okay, then we have security intelligence for domains and individual URLs. Authentication comes next. Then our application level policy. So at this point, we already know the applications from that place. So we can start to enforce the policy based on this information. We can perform classification for QoS. The enforcement is going to be performed at the LINA level. Okay, we can do host and user discovery. This is part of network discovery policy. This is used to build the host profiles and collect the user information. File control and malware analysis. So this stuff is known as advanced malware protection, versus this portion is responsible for blocking files based on their type, like for example PDFs versus docs. Okay, we have some application specific processing, and finally there is going to be that IPS. We handle the packet back to the LINA engine and then send it out to the network after the ASA components finish their job. As you can see, there could be a lot of different checks performed on the packet in the background, depending on what type of functionality we enable on the FTD. We don't have to use all of those policies, all of those features, but we potentially can. I also want to quickly look at the performance optimization. Stuff like this is going to be important for production deployments. So as I just said, there are a lot of different things that we can enable on FTD, and each of those features, each of those engines will take some of the CPU cycles. It will take some memory. So it's always good to think about optimization as we build our policies. And one of the most important things we can do on the FTD, in addition obviously to configuration tuning, like turning on, turning off some specific options, platform settings, playing with latency options, you can obviously do this, but a very simple thing you can do is just to think about how you build a policy. And in general, the policy should be subdivided into 3 sections. You should start with a basic layer 3-4 filtering based on IP addresses and port numbers. For example, I want to allow all ICMP communication, all ICMP pings from the inside to the outside. Okay, then I want to put more specific rules. I want to go to the application layer. I will be looking at the payload of the packets. Rules like that, I'm going to put after my basic layer 3-4 checks. And the logic here, of course, goes like this. If I know that I want to drop all TCP packets going over port 80, I don't really want to look at the payload of those packets, at the HTTP header and the payload of the HTTP header. I want to drop the packet based on the TCP port number. So it doesn't make any sense to involve application detection if you're eventually to drop the packet based on layer 3-4. This is why you put those basic rules on top of the policy. And finally, the third section, this is where you will put the most CPU and memory extensive rules, which is all about IPS and file policies. And a few other less important things you should take into account when you deal with FTD. The roles themselves ideally should be always built with the interfaces as one of the conditions. I'm now thinking about the access control policy. So at this point, you know that the interface must be associated with a zone or at least with an interface group. And those conditions, you should use them in the policy rule to narrow down the scope for the inspection engines. For instance, if you plan to allow web communication to your web servers on the DMZ, you want to use the DMZ interface as a condition because you don't have web servers on the inside zone. So it doesn't make any sense to look at packets that are destined to the inside if your web server is located on the DMZ only. Okay, then you should try to minimize the amount of conditions used in a rule. Like if you can build a rule based on the security zones, let's say all pings from the inside to the outside, it doesn't make any sense to specify those individual networks that are part of those zones if you are to list all of them. And note that grouping multiple conditions into a single object group is still not gonna increase the efficiency of the rule. It will not help with performance. And one more is gonna be, of course, to cut down on those most resource-intensive rules. I'm talking about IPS and file policies. That these features in most cases should be used very selectively and don't enable deep packet inspection on the traffic that is always trusted. That would be one example. Maybe you send a lot of backups every single day. Just exclude this traffic from the inspection.